Welcome to Cognato Key. Today, we're going to shine a light on a tiny piece of tech that, well, it has completely transformed our world, the LED.
I mean, just think about it. They are absolutely everywhere. From the screen you're watching this on right now, to the lights in your room, your car, you name it. But have you ever actually stopped to wonder what's going on inside these little glowing marvels? How do they do it?
So let's start with the absolute basics. An LED is a really special kind of semiconductor, and it has one amazing talent. It can turn electricity directly into light. It sounds almost magical, but this process has a scientific name, electroluminescence.
And its full name, Light Emitting Diode, pretty much tells you the whole story. It's a diode, which just means electricity can only flow through it one way, and when it does, poof, it emits light. A really simple but incredibly powerful idea.
Okay, now let's zoom right in. To really get how it works, we first need to see how this brilliant little device is actually put together, piece by piece. At the very heart of every single LED are two special layers of material that are fused together. One is called a p-type, and you can think of it as having tiny positive holes looking for an electron. The other is an n-type, and it's packed with extra negative electrons. And that point where they meet, that's the all-important p-n junction.
This core is then encased in a transparent epoxy shell. Now, this isn't just for protection. It's actually cleverly shaped like a tiny lens to gather all the light that's created and focus it outwards, which makes the LED appear much, much brighter.
And right at the very bottom, there's a tiny film of gold. Of course, this acts as one of the electrical connections, but it has a second, really clever job. It works like a tiny mirror, reflecting any light that happens to travel downwards back up to the top. This simple little trick makes a huge difference to the LED's efficiency.
Okay, so we've got all the parts, but how does this simple little setup actually create light when you connect it to a battery? Let's get into it.
Well, it all starts when you apply a voltage. This gives the electrons on the N side a push, sending them across the junction over to the P side. And what do they find there? All those holes we talked about. The electron and hole combine in a process called recombination. And here is the magic part. As the electron falls into this hole, it has to get rid of some extra energy, and it releases that energy as a tiny particle of light, a photon.
Now, what's really interesting here is the material. In older diodes made from something like silicon, this exact same process happens, but the energy is released as wasted heat. The real breakthrough for LEDs was using special materials like gallium arsenide, which have this unique property where the exact same process releases that energy as visible light instead. That is the whole secret.
Right, so now we know how one works, but what makes them so successful? And for that matter, how do they produce that whole rainbow of different colors we see everywhere?
Well, the secret to the color is all in the specific recipe of the semiconductor material. It's almost like being a chemist. By mixing different elements like gallium with arsenide or with phosphide, engineers can precisely control how much energy is released during recombination, and that in turn determines the exact color of the light.
And when you just look at all the advantages, it's pretty easy to see why they've completely taken over the world. They are incredibly efficient, just sipping tiny amounts of power. They last for years and years. On top of that, they're small, cheap to make, and you can control their brightness so easily. It's an unbeatable combination.
But they do have one big weakness, sort of kryptonite. They are very sensitive to electricity. If you let too much current flow through them, they can burn out in an instant. This is why you will always see an LED paired with a resistor in a circuit. That little resistor's job is to protect it.
All right, let's move to our final section and see how knowing all this stuff reveals the incredible impact LEDs have all around us, often in places you might not even expect.
Their very first and still most common job is as simple indicators. You know, that little light on your laptop or your TV that tells you the power is on. Because they're small, super reliable, and use almost no energy, they're just a perfect choice for this humble but very essential task.
From there, they graduated to actually displaying information. Those bright, sharp numbers on classic digital watches and calculators? Yep, all made from clusters of LEDs, giving us a clear readout that was just impossible with older technologies.
But here's the cool part. They also work in ways we can't even see. By producing infrared light, which is totally invisible to our eyes, LEDs form the basis of security systems. You know, when you break that invisible beam of light, that's what triggers the alarm.
And finally, on a global scale, they are the very backbone of the internet. In optical fiber communication, tiny LEDs or lasers are flashing billions of times per second.
encoding all our data, our emails, websites, this very explainer, into pulses of light that travel across continents in the blink of an eye.
So you see, this tiny piece of technology, born from a simple PN junction, has completely changed how we see information, how we secure our homes, and how we talk to each other. Which leaves us with one very exciting question to think about, doesn't it?
If you enjoyed learning how this amazing technology works, please do support the channel by liking this explainer, sharing it with someone who's curious, and of course, subscribing for more deep dives from Cognito Key. Thank you so much for watching.